Here's the first example. Looks like we have a V shape. Let's add on arrows on the end, students. We are going to fill out all of the characteristic, which is on the right side. Now, as you can see here, it's harder to see on my screen, but hopefully on your paper, it's a little bit clearer. As you can see, can you guys see that this right here is the x-axis right here in the middle? Okay, so I'm gonna draw that out so we can count it. It's somehow that just wasn't very clear. All right, so the vertex is right here. That is 0, comma, -3. Okay, when x is 0, y is -3, so the vertex is 0, -3. Looks like we have two x-intercepts. One is over here and one is over here. So looks like they are -3, comma, 0 and 3, comma, 0. The domain is talking about all values of x. Students, the arrows on the ends here, that means they go left and right forever. We're going to write this two ways, all real numbers using the R and the interval notation, which is from -infinity to infinity. This right here is called the interval notation, okay? Interval notation. Now, we just got done defining the word increasing interval. Increasing interval is when we write small x, comma, big X, right? Larger X. So it increases when y goes up. Well, y goes up when we have a positive slope. Can you, students, see that this is a positive slope? So it starts increasing at this x location right here. That's the lowest point. So obviously there's nothing else lower than that. So that point for x is 0. Now, where does it stop increasing? Arrow, meaning it goes up forever, indefinitely. So it like that, right? But how do we quantify if there's an arrow? We quantify it by using the symbol infinity. Again, that's why it's called increasing interval notation. We have to use it as 0, comma, infinity. So this right here is x1, comma, x2. It's a smaller x, comma, larger x. Rate of change, remember that is fancy for slope, right? So let's count. We're just going to count the slope really quickly. And usually when you count the students, just pick a nice point, okay? From here to here, it looks like rise over run. So rise is up, run is 1. Up 1, right 1. Now, but this absolute value symbol, this V shape also has the second line over here. So that's going to go what? Up 1, left 1. So on the right has a positive 1 slope. On the left has a -1 slope. So the rate of change for this is plus and minus 1. Or you can write -1, comma, +1. Okay. Minimum value. Minimum value is the lowest value. And we're going to use the y value. So the minimum lowest value at -3. Axis of symmetry. Axis of symmetry is based on your definition is a line that divides the graph into exactly 2 equal halves. So that means here's the line right here. That is the axis of symmetry. And this line is called x equals to 0. And the reason it's called x equals to 0 is because it intersects the x-axis. So axis of symmetry is x equals to 0. Y-intercept looks like we intersect the y-axis at 0, comma, 3. Yep, and that happened to be the vertex. And sometimes, yes, they can be the same answer. The range is all of the outputs, aka all of the y values, right, guys? Well, the smallest y value is -3. Oh, that does not look like a 3. Okay, -3. And again, this arrow means it goes up forever. When you say up forever, that means it's infinity above us. So the range, the smallest number is -3, and the largest is we don't know because it's infinity. So this is the interval notation. Now we could also write, or when you write both ways, y is going to be bigger than or equal to -3. Decreasing interval notation. Decreasing interval, students, remember, decreasing, when we write it in interval notation, we want to write smaller x, comma, larger x, right? So decreasing is when the y goes down. Y goes down means if we look at a line, there should be a negative slope. So another thing in years past, I said, can you slide down? Okay. Yes, wee. So if you can slide down, then that's decreasing. What is the smallest x? Well, again, this is going and going to the left forever. So that's going to be negative infinity. Where does it stop? It has to stop when it is the lowest. So the lowest value x happens to be at 0 for this question. So decreasing interval, students, is from negative infinity to 0. Now the vertex is usually, okay, again, I'm just going to give you a hint. The vertex is usually where the increasing and decreasing happens, or ends, I should say. Is this a one-to-one? One-to-one first, you have to say, is it a function? Okay, it does pass this vertical line test, so it is a function. Now, but does it pass the horizontal line test? No. One horizontal line test intersect at 2 locations. So what this tells me is that one y value has 2 different x locations, x1 and x2. So that is not a one-to-one. Even though it is a function, it's not a one-to-one function. Okay, students? Now, do we have a maximum value? A maximum value meaning that, hey, is there a highest value that we can pinpoint, we can locate? For this particular one, the answer is no. The reason we cannot find a highest of the highest value is because we have arrows. Arrows means they do go up forever. Because it goes up forever, we can't say which one is the highest. So maximum value, student, is NA or none.